Okay, so this is Lab 2. We are using Newton's second law to predict motion of a falling object. In this experiment, we are using weight force and drag force for our FNet interactions. I ran two different models, one with only weight force interacting on the ball, and the second model used both weight force and drag force. I again, in this experiment, used a racquetball with a weight of approximately 0.039 kilograms. In the video, you can see that I used a tape measure set to 2 feet or 0.609 meters to set the distance for a tracker. So let's go ahead and view that video. As you can see, I got 16 data points and got my good time, my initial velocities and ball position, so that we can then come to Python. And in Python, get to the right point here. Okay, so my overall time was going to be 0.533 and set the initial ball velocity and ball positions with the appropriate math and physics. You can see here that I have already done the equation for drag force, but as you can see for FNet at this running of this model, it's not included in Python. So let's go ahead and run this and see what our model looks like. Okay, it looks fairly accurate to what the video showed. Close that and get it out of our way. So you can see here, though, that the ending position of the ball is not quite what we were seeing over here on the actual tracker. So let's go ahead and take a look at the plot. So here we go. This is Model 1. And we can see that as we saw, the predicted was not the same as the experimental plots. The experimental plots weren't falling as fast. Alright, so let's go ahead and jump back to Python and change the function here so that we can now see it with drag force. Okay, again, looks about exactly like we expected it to. But we can see here that this got a lot closer to what our end position was. So let's go ahead and take a look at that plotted out. And as we can see here, we got an awful lot closer with our predicted models and our experimental positions. So in Python, I actually tabulated B for drag force as 0.02, and that got me my model points a lot closer than leaving it out. So then let's go ahead and go back. So as we can see there, obviously with just weight involved in the model, we were off. With adding drag force, we can see that the model became a lot more closer to the predicted model. What if, however, we threw the ball versus dropping the ball? How would that affect terminal velocity? Well, we can see from tracker here, or let's go ahead and use the plot point from the model. That's our velocity. You can see it's the experimental model. It's actually starting to pick up. It's still kind of picking up speed versus the kind of consistent basis that the predicted model was using. Throwing it, we can see, or we would expect to see, that the ball would pick up speed a lot faster, and therefore it would fall a lot quicker. So we should see it drop off a lot faster. All right, and that should end that experiment.